Today we're going to look at section 10.3, which deals with geometric sequences and series. When we talk about a geometric sequence, you're going to be seeing that each of the sequences given have a common ratio. We call that ratio the R value. And basically, when I say ratio, I mean you're going to multiply by the same value to get to each term. So unlike arithmetic, where we add or subtract, you're going to see that we are multiplying by the same value each time. Now, there's a little trick. If you want to find the common ratio and it doesn't look obvious to you, you could take any term and divide it by the previous term. So for example, if you want to find the common ratio, you can take A2, the second term, and divide it by A sub 1, the first term, and that should give you that common ratio. Now, if you want to confirm that that is the common ratio, you can also take A3 and divide it by A2 and make sure you get the same number, or you could just test it. You can take the number you find for that common ratio and just multiply each term by it to see that you get each term of the sequence. So there's two different ways you can write rules for this, explicit versus recursive. I'll go through each in the first problem. So for the first problem, if you can't identify what value are you multiplying each time to get to the next term, then you can use that little trick where you take, where are we going? The second term and divide it by the first. So if you wanted to do the little trick, you would take the second term, which in this case is 10/3, and you would divide it by the first term. And then if you do the multiplying by the reciprocal, and then we reduce 10/2, you would get that value of 5. Now, again, this isn't necessary if you saw right away, oh yeah, we're multiplying the top by 5, the bottom staying the same, so that's like multiplying by 1. If you got that common ratio of 5 that way, that works as well. Now, when you write a recursive formula, remember that for recursive formulas, you always have to say what that first term is. It's very important. For the rule, think about recursive. What am I doing to the second term to get to the third? What am I doing to the third term to get to the fourth? I'm always multiplying by that value of 5. So what you're going to say is 5 times the previous term. So remember that when we write recursive rules, we use that a sub n minus 1. You'll even see if you, I can't do it because my screen just froze. I don't know why my screen keeps freezing on me. I think it's because I'm using Desmos and they I don't know, fight with each other or something. I don't know. But you'll see up here where it says recursive formula that you always want to write that first term and then r times. And remember, this right here represents the previous term. So I'll put that in like parentheses that means previous term. So you always want to make sure that that's there when you're writing a recursive rule. So that would be our final answer for part B. Now for part C, you guys are going to love this. If it says write an explicit formula, I want you to note that the explicit formula here is actually just writing an exponential function. And it makes sense, right? Think about exponential function. You're multiplying by that base number however many times. So what you're seeing here is that we keep multiplying by 5. Well, that would represent the b value, that base number for our exponential function. So if I said write an explicit formula, you always start by writing the first term, so that's 2/3, and then that common ratio value, which in this case was 5, to the n minus 1. And that's it. You're going to love this formula because you don't have to do the same type of math that you had to do with the arithmetic. Now, check to see if this works. If I sub in an n equal to 1, I should get 2/3, and it makes sense why you do, because remember, if you sub in n equal to 1, the exponent becomes 0, and remember 5 to the 0 power is just 1, and then when you multiply that by 2/3, you get 2/3. If I sub in n equal 2, notice that that would give me 5 to the first power, so I'm actually multiplying that 2/3 by 5 one time, and that's how I'm getting that 10/3. So it makes sense that that would work. Now, if you want to find the 10th term, we are going to sub in a 10. Keep in mind, you're really multiplying by that ratio only 9 times, which is why when you sub in that 10 minus 1, it's giving you a 9 up here. Definitely want to use my calculator for this one. You're going to get really big numbers for these. Uh-oh, that's not what I want. Got a lot of things open up. So if you go to your calculator and we take 2/3 and we multiply that by 5 to the 9th power, this is going to get big, you're going to get this value of approximately 1302083.333. You're going to get this 1,302,083.333. I guess that is exact. I don't know. I think that's being rounded, but that's okay. So that would be your final answer for this one right here. Now, there is a question number 2 on here that is very similar to something you saw with arithmetic. If I say find the first term of a geometric sequence, but I give you 2 terms that are not the first term, let's think about this. We have first term, second term, third, fourth, fifth. If they tell you that term 2 is equal to 6 and term 5 is equal to 162, and they want us to find the first term, so a sub 1, think about what we did with arithmetic. Remember with arithmetic, we added the common difference. Well, here, think about how you're going to multiply by the common r value to get to the third term. You're going to multiply by it again to get to the fourth term. And then you're going to multiply by it one more time to get to the fifth term. If you think about what this says, it really says 6 times r to the third power is going to equal 162. So really, you're getting that equation from this right up here, which makes sense that we would multiply by r instead of add a common difference however many times. Now, when you solve this, just divide by 6, you're going to have flashbacks of what we did last unit, because this is what we were doing there. So let's see, this is going to be 2, and then that would give me 42/27. And then we could take the cube root of this, and you're going to get an r value equal to 3. That means that to get from A2 to A3, we would multiply by 3. That would give me 18. And then if I multiply by 3 again, you'll see that that would get you to each term. Now, the problem is I want to find what a sub 1 is. So from here, you have 2 different options. Since it's only 1 term away, it's very easy to go the other way. If I want to go to the left, I'm going to divide by that r value, and that would give me a value of 2. So very easily, I get a sub 1 equals 2. But let's just say you had found, they gave you the 27th and the 50th term, and then they said find the first term. Second option is you could also write a rule. A sub n equals the first term times the common ratio to the n minus 1. And if you want to find that first term, you can just fill in that common ratio you just found of 3. So we can rewrite this as a sub 1 times 3, and then use one of the givens. If I know that the second term is 6, what I could do is I can fill in a 6 and then a 2, and then I can solve this. Because think about this right here is a value. This would give me 3 to the first power, or 3. So what I get is 6 equals a sub 1 times 3. And then if I divide, you're going to get this value of 2. I think that there is a quizzes question that deals with doing something like this. So it's really good to just see that second way as well. Final question for the first part of the notes today deals with a word problem. You will get practice with this with Delta Math. Delta Math deals with some word problems, some application, and you also do see this in the quizzes. So with this one, they're giving you the price of a house during the first year of ownership. During each year of ownership, the value of the home appreciates, which means it's worth more. So if we want to write an explicit formula, think about this, guys. This is just last unit. This is exponential. We know that the starting amount is 430,000, and if it's appreciating, it's going up by 3%. Now, normally when we set up these formulas, we would just have like x in the exponent. But think about how it actually, during the first year, is 430,000. If I put just n here, and you can also simplify this as to 1.03, if I fill in a 1 for n, that's not going to give me the first year. that's actually going to take the 430,000 and you would multiply it by 1.03. We don't want to do that until the second year, so I have to put that n minus 1. Because note, if I fill in now a 1, it's going to make the 1.03 become 1 when I raise it to the 0 power, which would give me that starting amount of 430,000. So that would be your explicit formula. And then for part B, you would do a sub 10. So keep in mind that it's going to go up 9 total times, which is why our exponent becomes 10 minus 1, or 9. And then we can see how much our house is worth. 430. And then we're going to multiply that by 1.03 raised to the 9th power. And we're going to get approximately 561,052 and approximately 47 cents. So that is the first part of the notes. I am going to create a second video to show you how to find sums.